Welcome to G Fun Facts Online. Today, we're unraveling the story of a man who unlocked the very code of life, only to become a pariah in the world he helped create. This is the complicated legacy of James Watson, the co-discoverer of DNA's double helix. His life's work reshaped our understanding of biology, but the brilliance of his mind is tangled with a pattern of offensive remarks that stained his reputation and forced a difficult reckoning with the man behind the monumental discovery. Born in Chicago in 1928, James Watson was a prodigy. He entered the University of Chicago at just 15 years old. His early passion was for birdwatching, but that changed dramatically after he read Erwin Schrödinger's 1944 book, What is Life? The book proposed that genes held the secrets of life, and this idea ignited in Watson a fascination with genetics that would steer the course of his entire career. After earning his PhD from Indiana University, Watson's journey took him to Europe. The critical moment came at a conference in Naples in 1951. There, he saw an X-ray diffraction pattern of crystalline DNA, presented by a scientist named Maurice Wilkins. This image was a catalyst. It convinced Watson that the structure of DNA was not an unsolvable mystery. His ambition led him to the Cavendish Laboratory at the University of Cambridge, where he met Francis Crick. The two shared a powerful conviction that understanding DNA's structure was the absolute key to understanding heredity. This was a bold stance. At the time, the prevailing scientific view was that proteins, being more complex, were the carriers of genetic information. DNA was dismissed by many as a stupid tetranucleotide, a simple structural molecule. But Watson and Crick, influenced by earlier experiments suggesting DNA was the genetic molecule, thought otherwise. Their method was a hands-on approach of model building, assembling the molecular components of DNA like an incredibly complex puzzle. They weren't working in a vacuum, however. A fierce, unspoken race was on. A team at King's College London, which included Maurice Wilkins and a brilliant crystallographer named Rosalind Franklin, was also closing in on the answer. It was Rosalind Franklin's meticulous and groundbreaking work that provided the final, crucial pieces of the puzzle. She was an expert in X-ray crystallography, a technique used to determine the atomic and molecular structure of a crystal. By carefully controlling the water content of her DNA samples, she produced stunningly clear images of the molecule. In May of 1952, she captured a particularly clear image of what was called the B form of DNA. This image would become famously, and perhaps infamously, known as Photo 51. In early 1953, Maurice Wilkins showed Photo 51 to James Watson. Crucially, this was done without Rosalind Franklin's knowledge or consent. For Watson, it was a moment of pure revelation. He later wrote in his book The Double Helix, "The instant I saw the picture, my mouth fell open and my pulse began to race. The distinct X-shaped pattern in the photo was an undeniable sign. It screamed helix." This critical insight, combined with other data from a King's College report that Watson also gained access to, gave Watson and Crick everything they needed. They were able to rapidly finalize their model. In April 1953, they published their findings in a brief, elegant, one-page paper in the journal Nature. They proposed the iconic double helix structure for DNA, a twisted ladder. But their paper did more than just describe the shape. It also ingeniously suggested how this specific structure could allow the molecule to unzip and make copies of itself, thus explaining the very basis of heredity. It was, as Watson would later declare, the discovery of the century. The discovery of the double helix was a monumental turning point for science, kicking off the modern era of biology. In 1962, Watson, Crick, and Wilkins were jointly awarded the Nobel Prize in Physiology or Medicine for their discovery. But a key figure was missing from the ceremony. Rosalind Franklin, whose data had been so pivotal to their breakthrough, was not included. She had tragically died of ovarian cancer in 1958 at the young age of 37, and the Nobel Prize is not awarded posthumously. Over time, the full extent of her contribution and the dismissive, even misogynistic treatment she received detailed by Watson himself in his own book, would become a central and painful point of criticism in the story of the discovery. Following the Nobel win, Watson's career continued its meteoric rise. He spent time at Caltech and Harvard, where he wrote the hugely influential textbook, Molecular Biology of the Gene. Then, in 1968, he took on a new challenge as the director of the Cold Spring Harbor Laboratory on Long Island, New York. When Watson took over, the lab was struggling financially. Over the next 4 decades, his leadership transformed it into a world-leading research powerhouse for molecular biology. He focused the lab's efforts on cancer research, leading to a deeper understanding of cancer-causing genes called oncogenes. He was also a driving force behind the Human Genome Project, the ambitious international effort to map the entire human genetic code, serving as the first director of the National Center for Human Genome Research. He famously championed the idea that the human genome belongs to all people and argued against the patenting of gene sequences. But parallel to this celebrated career, a much more disturbing side of James Watson was emerging. Throughout his later life, he made a series of public statements that were widely condemned as racist, sexist, and homophobic. These weren't just one-off mistakes. They formed a pattern of expressing views that many found reprehensible and, importantly, unsupported by science. For example, in a 2000 speech, he suggested a link between skin color and sex drive. He hypothesized that dark-skinned people have stronger libidos, remarking, "That's why you have Latin lovers. You've never heard of an English lover. Only an English patient." He also made disparaging comments about women in science and suggested that if a gene for homosexuality were discovered, a woman should have the right to abort a child if she didn't want them to be gay. The most significant and damaging controversy, however, erupted in 2007. In an interview with the Sunday Times of London, Watson stated that he was, quote, "inherently gloomy about the prospect of Africa because," he claimed, "all our social policies are based on the fact that their intelligence is the same as ours, whereas all the testing says not really." He went on to add that people who have to deal with black employees find this is not true. The international uproar was immediate and fierce. The scientific community, including the very institutions he had built and led, moved quickly to distance themselves. Cold Spring Harbor Laboratory suspended him from his position as chancellor, and he officially retired a week later. Though he issued an apology, the damage to his legacy was profound and permanent. The final, damning chapter of his public disgrace came more than a decade later. In a 2019 PBS documentary titled American Masters: Decoding Watson, he was asked if his views on the link between race and intelligence had changed. His answer was an unequivocal, "No, not at all." He elaborated, saying, "There's a difference on the average between blacks and whites on IQ tests. I would say the difference is, it's genetic." This public reaffirmation of his long discredited and racist views was the final straw. Cold Spring Harbor Laboratory, the institution he had built into a global powerhouse, took the unprecedented step of revoking all of his honorary titles, including Chancellor Emeritus. In a powerful statement, the lab condemned his remarks as reprehensible, unsupported by science, and a blatant misuse of science to justify prejudice. He was effectively cast out from the community he had once ruled. His speaking engagements dried up. In 2014, citing a need for money after his fall from grace, he became the first living Nobel laureate to auction off his prize medal. It was purchased by a Russian billionaire who, in a surprising turn, later returned it to him. James Watson's legacy is both monumental and deeply troubling. He was, without question, a scientific giant. His co-discovery of DNA's structure unlocked the blueprint of life itself, setting in motion decades of progress that have given us everything from personalized medicine and gene therapy to forensic science. The impact of his work is immeasurable. Yet, it is impossible and irresponsible to separate the scientist from the man. His relentless promotion of genetic determinism and his racist and sexist pronouncements stand in stark, ugly contrast to the elegant beauty of the double helix. As Francis Collins, the former director of the National Institutes of Health, lamented, "I only wish that Jim's views on society and humanity could have matched his brilliant scientific insights." The story of James Watson is a powerful cautionary tale. It forces us to confront the uncomfortable truth that genius and bigotry can, and do, coexist in the same person. It compels a necessary conversation about scientific ethics, the responsibility that comes with a public platform, and the enduring need to acknowledge all contributors to a discovery, especially those, like Rosalind Franklin, who were initially written out of the narrative. In the end, James Watson's legacy is a complicated tapestry, woven with threads of brilliant discovery and profound prejudice, a legacy that science and society will be grappling with for generations to come.